Hello everyone, my name is Pontus Loviken and I'm the main author of the paper Online Learning of Body Orientation Control on a Humanoid Robot using Finite Element Goal Babbling. So in this work, we asked ourselves the following question. How can you learn from scratch to control a body with many degrees of freedom if the only way you can acquire such skill is by interacting with a real environment? This is an interesting problem, not least because it's the exact same problem we face as humans and animals when we're born. Yet, depending on how you define the body orientation control problem, it's a problem for which most common machine learning methods fall short. And there are basically two reasons for this. So the first thing is that you have very sparse training data as you need to collect everything in the real world, and you only have a limited time. And the second thing is that you have a vast state and action space. When you have high-dimensional bodies with continuous joints, there are infinitely many configurations you can find yourself in, and for each of those configurations, there are an infinite number of actions you could do. And a way to get around this problem is to, instead of focusing on exploring everything you can do, to pick a low-dimensional parameter that you want to control, and then only focus on actions that have some novel influence over this parameter. In this case, this is the angle phi, where phi roughly corresponds to how much on the side the robot is, with an angle 0 being completely on the back. To learn this control, it's however not enough to learn one posture for every rotation here, because body orientations are not uniquely defined by the posture you have. So as you see in this case, for example, you have two robots and they reach the same final posture, but one ends up standing up and the other one ends up lying down. So to control the body orientation, it's not enough to learn what posture to reach. You also must learn from what context to reach it. In a previous paper, we introduced the method Finite Element Goal Babbling in the case of a simulated planar arm of 100 degrees of freedom or more, and showed that although an inverse model can't be used to immediately reach between any two end effector positions here, it can be used locally in smaller regions, and then you can learn at a higher level how you can move between these different regions using these inverse models. So now we wanted to see if this also works for a real physical system and for the body orientation problem. So in this case, after around 20 minutes of interaction with a real world, it had built kind of a map like this, and it learned to do the sequence between these as well. And to give you a better insight in the process, I want to show you a video. So here you see that the robot starts on the back, and it finds how to move a little bit to the side, and then it will learn how to move even further out to the side. And I realize you won't be able to see the full video, but you will be able to see it if you come to my session later. But now after 15 minutes, it can go all the way up to the side. And what I want to show later is that you can actually tell it to go between the sides. And you can follow the link here if you want to implement this on your own now. And thank you. See you in the session later.